Hello everyone, welcome to my channel Strongmath. Today we'll discuss about the rest of the properties of class 8 first chapter, which is named as rational numbers. Today we'll discuss about commutative property, associative property, distributive property and many more, and you will know how to solve some problems related to this chapter. So watch the video till the end, don't skip the video. The first property is commutative property. What is commutative property? Suppose you are taking two numbers, any numbers a and b, okay, and we assume the operation addition. The commutative property states that if a plus b equals to b plus a, then we say that these two numbers are commutative under the operation addition. Okay, if a plus b equals to b plus a, then we say that the commutative property holds for addition. So different kind of operations, there will be different kind of results. They may be commutative, they may be not. Now let's discuss the operation addition and the different numbers. Suppose whole numbers, take the whole numbers are 0, 1, 2, etc. Take any two whole numbers, say 1 and 2. We are doing the operation addition. So if 1 plus 2 is equals to 2 plus 1, then we say that whole numbers are commutative under addition. Are they equal? Yes, obviously they are equal, because 1 plus 2 gives us 3, and here also 2 plus 1 gives us 3 also. As 3 and 3 are equal, hence we say that for every whole numbers, the whole numbers are commutative under addition. So whole numbers are commutative under addition. Similarly for natural numbers are 1, 2, 3, etc. Take any two naturals, 5 plus 2 is 7, and 2 plus 5 is also 7. So we can write 5 plus 2 is equals to 2 plus 5. So natural numbers are also commutative under addition. Okay. Next, for integers and natural numbers, take any two integers, suppose minus 2 and 3, and if we add them, minus 2 plus 3 is equals to 1. Now take reverse, 3 plus of minus 2 is equals to also 1. So we can write minus 2 plus 3 is equals to 3 plus minus 2. Similarly for rational numbers, they are also commutative. So for integers and rational numbers, they are commutative under addition. Okay. Next we will discuss about subtraction. For whole numbers, say 0, 1, 2, 3, etc. Let us take 5 and 3 and subtract them. 5 minus 3 gives us 2. Take reverse, 3 minus 5 gives us minus 2, but minus 2 and 2 are not equal. So here we say that 5 minus 3 is not equals to 3 minus 5. So subtraction is not commutative. Okay. So whole numbers are not commutative under subtraction. Similarly, if we take natural numbers 1, 2, 3, you can easily find out. Say we are taking 3 and 1 and subtract them. 3 minus 1 gives us 2. 1 minus 3 gives us minus 2. They are not equal. So natural numbers are not commutative under subtraction also. Similarly for integers, if we take minus 2 and 0 and subtract them, minus 2 minus 0 gives us minus 2, but 0 minus of minus 2 gives us 2. They are not equal also. So integers are also not commutative under subtraction. Similarly for rational numbers, take half minus 2 by 3 gives us minus 1 by 6, which is not equals to the second part, that is 2 by 3 minus half. So rational numbers are also not commutative under subtraction. Let us explain different kind of numbers under multiplication. Take any numbers, suppose for whole numbers 0, 1, 2, 3, etc. Multiply any two numbers. 2 into 3 gives us 6, which is equals to 3 into 2. Forward and backward numbers under same operation, which is multiplication, are equal. So whole numbers are commutative, okay, under multiplication. Similarly you can check for natural numbers also, as well as integers also, and rational numbers also. How? For rational numbers, take an example, 2 by 3 into 6 by 5, and this will gives us 4 by 5. Taking backward, that is, at first write 6 by 5, then 2 by 3, multiply them, then this will gives us 4 by 5 also. So all the numbers are commutative under multiplication. Clear? Now for the operation division, whole numbers, suppose we are taking 1 and 5. Now divide them. 1 divided by 5 is equals to 1 by 5, and 5 divided by 1 gives us 5 only. So clearly 1 by 5 is not equals to 5. So the whole numbers or natural numbers are not commutative under division. Okay. Similarly, if we choose any integers, suppose 5 and 10, now divide them. 5 divide 10 gives us 5 by 10, which is equals to half. Now reverse them, that is 10 divide 5 is equals to 2. 2 and half are not equal, so integers are also not commutative under division. Similarly for rational numbers, if we take half and 1 by 3 and divide them, half divided by 1 by 3 gives us 3 by 2, and if we divide 1 by 3 by half, we will get 2 by 3. Both are not equal, so also for rational numbers are not commutative under division. That is, for all the numbers are not commutative under division. Clear? Next property is associative property. What is associative property? Suppose there are three numbers a, b, c, say integers, and we take the operation addition. Okay, now if this happens, a plus b plus c, at first we add b plus b and c, and then it add with a. Okay, and if the result becomes to equal a plus b plus c, then we say that the numbers are associative under addition. This is the property. Okay, now we'll explain for different operations for different numbers. Suppose we are taking the whole numbers 0, 1, 2, 3, etc. For any three numbers, say 1 plus 2 plus 3 gives us 1 plus 2 plus 3, 2 plus 3 is 5. So 1 plus 5 gives us 6. Now taking this order, that is a plus b plus c, that is we have to calculate 1 plus 2 plus 3. This equals to 3 plus 3, which is also 6. So whole numbers are associative under addition, as well as the integers are also associative, as well as the rationals are also associative, and integers are also associative. So all the numbers are associative under addition. Okay, all the numbers are associative. Now if we choose subtraction, so for subtraction, take 1 minus 2 minus 3 gives us 1 minus minus 1, 1 minus minus plus, 1 plus 1 equals to 2. Now taking reverse, 1 minus 2 minus 3, 1 minus 2 gives us minus 1 minus 3, which is equals to minus 4. So clearly all the numbers are not associative under subtraction. I hope you can easily understand. Now for multiplication, if we choose for rational numbers 1 by 2, 1 by 3 and 2 by 3, now multiply them. At first we have to multiply these two numbers, then multiply with this number, then this will give us 1 by 2 into 2 by 9, which is equals to 1 by 9. Now taking the order as 1 by 2 into 1 by 3, then multiply with 2 by 3, will get 1 by 6 into 2 by 3. This is also equals to 1 by 9. So rational numbers are associative under multiplication. What will happen for all the other numbers? For example, we are taking 1, 2 and 3 very simply. So this will give us 1 into 6, which is equals to 6. Taking order as 1 into 2, then 3. This will give us 2 into 3, which is also 6. So for all the numbers are associative under multiplication. Now what about division? For division, look, if we divide 12, if we write like this, 12 divided by 4 divided by 2. At first we have to do this division. Then this will give us 12 divided by 2, which is equals to 6. Now taking the order like this, 12 divided by 4 divided by 2. This will give us 3 divided by 2, which is equals to 3 by 2. Clearly they are not equal. So you can easily check for other numbers, that is for rational numbers, for whole numbers, to check this property, and you will see that all the numbers are not associative under division. All the numbers. Okay. Let's move on to another important property, which is known as distributive property. Suppose there are two operations, addition and multiplication. Okay. Suppose there are three numbers a, b, c, say integers. This is symbol of integer. Now if a plus b into c is equals to a into c plus b into c, then we say that multiplication is distributed over addition. Why? Look, here the operation multiplication is distributed with the elements a and b also, right? That is a plus b into c equals to, we write a into c plus b into c. So clearly this operation multiplication is distributed over the operation addition. Now if we write a into c plus b, then can we write this equals to a plus b into c plus b? Check. Suppose 2 into 3 plus 5. If we multiply them, then 6 plus 5 is equals to 11. Now if we write like this, that is 2 into 5 plus 3 into 5, then this will gives us 10 plus 15, which is equals to 25. This is not possible, so this is not true. But for distributive law, you can write like this. This is true. A plus b into c equals to a into c plus b into c. Now the identity element. Suppose we are taking the operation addition. A plus something gives us a. Suppose you are asked to fill in the blanks. Which element is to be added with a such that we get a? Clearly 0, right? Similarly, something element plus a equals to a, obviously that element will be 0. Observe it very carefully. Now if we consider multiplication, then a into something gives us a. Which element will be placed here? Obviously 1. We know that a into 1 equals to a. Similarly, 1 into a gives us a. That is, for any operations, whether it may be addition or multiplication, the element is called identity element, for which under those operations we can get the same element. Okay, clear? Here we say that 0 is the additive identity. Clear? So look, 0 is called the identity for addition. That is, Suppose 2 plus 0 equals to 2. 1 by 2 plus 0 is also half. 4 plus 0 equals to 4. So 0 is called the identity element for addition. Now the number 1 is called the identity element for multiplication. I hope you can understand easily that 1 into 4 equals to 4, 2 into 1 equals to 2, 3 by 5 into 1 is equals to 3 by 5. So these numbers are called the identity element because after doing the operations with any other elements we get that same element. Hence these numbers are called the identity element. Remember these elements very carefully. Next, negative of a number. If I ask you give some examples of negative numbers, you can easily say that -1, -3, -5 are negative numbers, right? So it is very obvious that for an integer a we have the negative of a as minus of a, right? And we have a plus of minus a is equals to 0. For addition we have already learned that 0 is the identity element. So a is the negative of minus a. Clear? Here we also say that minus a is the additive inverse of a. Okay, additive inverse. Next we will discuss that one. Look, reciprocal of a number. Suppose a be any number, okay, then the reciprocal of a is 1 by a, or we can write it a to the power minus 1. Clear? So reciprocal of a is 1 by a or a inverse. Now multiplicative inverse. For additive inverse we say that a plus negative of a equals to 0, hence negative of any element is its additive inverse. For multiplicative inverse, for an element a into its reciprocals gives us identity element 1, right? 1 is the identity element for multiplication. So any reciprocal number of a number is the multiplicative inverse. Now remember this one, 0 has no reciprocal. We know that reciprocal means 1 by a is the reciprocal of a, right? For 0, 1 by 0 will be the reciprocal, but we know that we can't divide any number by 0. So 0 has no reciprocal. By using the above concept, we have to find the additive inverse of minus 7 by 19 and 21 by 112. For any element a, the additive inverse is minus a. So simply the additive inverse of minus 7 by 19 is 7 by 19. For 21 by 112, the additive inverse is minus 21 by 112. That is the negative of that number is called the additive inverse. Next one, using the appropriate property find this sum. Here look, minus 2 by 3 into 3 by 5 plus 5 by 2 minus 3 by 5 into 1 by 6. Clearly here 3 by 5 in common in these two portions. So we can easily taking common 3 by 5 and minus 3 by 5, and we can write 2 by 3 plus 1 by 6. Which property we are using here? We are using distributive property. Plus 5 by 2. This equals to minus 3 by 5 into taking the sum. This will gives us 4 plus 1 plus 5 by 2. This is equals to minus 3 by 5 into 5 by 6 plus 5 by 2. If we cancel out, then we will get minus half plus 5 by 2. Now simply we add them. then this will gives us 4 by 2, which is equals to 2. So the answer is 2. In the second problem, 2 by 5 into minus 3 by 7 minus 1 by 6 into 3 by 2 plus 1 by 14 into 2 by 5. Again we have to apply the properties. Look here, 2 by 5 and there is 1 2 by 5. So we can take it common 2 by 5 and write them minus 3 by 7 plus 1 by 14. We are using the distributive property here also, and this will gives us minus 3 to the 6, so minus 1 by 4. This will gives us 2 by 5 into, taking the LCM as 14, will get minus 6 plus 1 minus 1 by 4. Okay, this is equals to 2 by 5 into minus 5 by 14 minus 1 by 4, cancelling out 5 and 5 and simplify it, will get minus 1 by 7 minus 1 by 4, which is equals to minus, taking the LCM as 28, will get minus 11 by 28 as the result. So here you have to remember which property we are using. Next, write the multiplicative inverse of 1 by 5. Remember one thing, suppose a is any number, its multiplicative inverse is 1 by a, its reciprocal is the multiplicative inverse. So clearly for number 1 by 5, its multiplicative inverse will be 5. Number 2, for minus 12, its multiplicative inverse will be minus 1 by 12. For 3, 0, its multiplicative inverse is not possible, right? Because we can't take 1 by 0. Okay, and for 4, the multiplicative inverse will be 1 into minus 1 into minus 2 by 5, that is 2 by 5. So its inverse will be 5 by 2. Okay, just take the reciprocal of a number for multiplicative inverse. Remember, for additive inverse we have to take the negative numbers, and for multiplicative inverse we have to take its reciprocal. Clear? Name the property under multiplication. Minus 2 by 3 into 1 equals to 1 into minus 2 by 3 equals to minus 2 by 3. Which property is this? Clearly here 1 is present. Some element into 1 equals to 1 into that element equals to that element. So clearly this is the property of identity. Now minus 5 by 2 into half equals to half into minus 5 by 2. Here it is in the form of a into b equals to b into a. Remember which property? Commutative property. Here we are discussing all the possible problems related to this chapter. You can easily find out this kind of problems in your NCERT books and your reference books. At first, look how to solve the problems and try at home to solve the other problems from your books. Next, multiply 7 by 13 by the reciprocal of 14 by 26. So we have to multiply 7 by 13 into reciprocal of 14 by 26 is 26 by 14, right? So this is equals to 13 to the 26, 7 to the 14, 2 to cancel out 1. Very simple problem. Next is 8 by 9 is the multiplicative inverse of minus 1 by 1 by 8. Here the number is 8 by 9 and we have to check with minus 1 by 1 by 8. This equals to minus 9 by 8. Look, for multiplicative inverse, the multiplicative inverse of 8 by 9 is 9 by 8, but it is given minus 9 by 8. Both are not equal. Since 9 by 8 is not equals to minus 9 by 8, hence this is not the multiplicative inverse of the given number 8 by 9. Clear? So I hope you can understand today's lecture. If there is any kind of query or doubt related to today's topics, then please do comment below. And look at the screen. Here is some problems for your homework. Here there are given 4 fill in the blanks, and another one, representation of rational numbers on number line: 2 by 3, minus 5 by 7, 12 by 5, minus 10 by 3. In the previous class, that is in class 7, you have already learned how to represent a number on a number line. So try yourself at home. Thanks for watching this video. Please like, share and comment, and obviously please do subscribe my channel StrongMath. Mention your query. Keep watching. Thank you.